Have you ever looked up at the sky and dreamed of flying faster than sound, of crossing continents in the time it takes to watch a movie? For decades, that dream was a noisy reality, then a distant memory. But now, something is stirring in the heavens once again. In the boundless sky where humankind once gazed with wonder, a new sound, or rather the absence of it, marks the beginning of a bold new era. In early 2025, NASA's X-59, the world's first quiet supersonic jet, sliced through the air above the California desert, completing its historic maiden flight. This wasn't just another plane taking off. It was the first step toward restoring something the world lost over 2 decades ago: supersonic flight. But this time, without the thunderous booms that once shook cities and shattered windows. With this single, carefully orchestrated flight, NASA and its partner Lockheed Martin have reignited the dream of supersonic passenger travel. For years, the word supersonic was synonymous with the legendary Concorde. That elegant spear of an aircraft once flew passengers across the Atlantic at twice the speed of sound, turning a 7-hour journey into less than 3. But its reign ended in 2003, brought down by its deafening sonic booms, high costs, and limited routes over the ocean. Since then, engineers and dreamers have longed for a way to bring back supersonic travel for everyone. Enter the X-59 Quest, short for Quiet Supersonic Technology. This sleek, needle-nosed jet is NASA's answer to one of aviation's oldest challenges: how to break the sound barrier without breaking the peace. It's 96 feet long, but only 29 feet wide, with a sharp nose stretching nearly a third of its length. It looks less like a plane and more like a futuristic dart built to pierce the heavens. But its true genius isn't just its shape. It's the symphony of science and engineering woven into every rivet and curve. So, how does it work? When an aircraft flies faster than sound that's about 760 miles per hour, it creates shock waves that merge into a powerful pressure wave. On the ground, we hear this as a sonic boom, a sudden, explosive sound. During the Concorde era, these booms were so disruptive that supersonic flight was banned over land in the United States and many other countries. The dream of flying coast to coast at Mach 2 was crushed not by technology, but by our tolerance for noise. NASA's mission with the X-59 is to completely change that equation, to transform the dreaded boom into a barely noticeable thump. The jet's entire design revolves around this one goal. Its incredibly long, 30-foot nose is specially shaped to spread out the shockwaves, preventing them from merging into one violent wave. Its engine, a powerful General Electric F414, is mounted on top of the fuselage, not below, which helps redirect sound away from the ground. Even its wings and tail are meticulously crafted to balance speed with quiet. Together, these innovations create what NASA calls shaped sonic boom technology. Instead of a thunderclap, people on the ground would hear something closer to a distant car door closing, a sound so quiet it might go unnoticed in a busy city. This extraordinary feat was achieved through years of computer simulations, wind tunnel tests, and small-scale experiments at NASA's Armstrong Flight Research Center and Lockheed Martin's legendary Skunk Works, the same facility that brought us the SR-71, Blackbird, and the F-117 Nighthawk. Engineers used advanced software to model how every inch of the X-59 would interact with air at supersonic speeds. Its precision on an unimaginable scale, where a tiny change could be the difference between silence and shock. The X-59's first flight was the culmination of over a decade of work. As it lifted off from the dry lakebed at Edwards Air Force Base, its takeoff was smooth and deliberate. While it soared, testing its stability and handling, engineers held their breath. This wasn't just a test. It was proof that the once impossible was now a reality, forged in aluminum and carbon fiber. When the flight succeeded, cheers erupted in control rooms across NASA. Inside, the cockpit is another marvel. Because of that incredibly long nose, the pilot can't see directly ahead through a traditional windshield. Instead, the X-59 uses a high-tech system called the External Vision System, or XVS. It's a combination of forward-facing cameras and high-resolution displays that give the pilot a clear, synthetic view of the world. This digital vision system integrates sensor data and terrain mapping to provide a view even better than the human eye, allowing for precise landings without compromising the jet's sleek, quiet design. So what's next? The X-59 is a flying laboratory, not a passenger plane. Over the next few years, NASA will fly it over select U.S. cities. Volunteers on the ground will record their reactions to its quiet sonic thumps, providing crucial data on how acceptable these sounds are for everyday life. If successful, these findings could convince regulators like the FAA to finally lift the ban on supersonic flight over land. The implications are profound. Imagine boarding a plane in Los Angeles and landing in New York in under 2 hours, or flying from London to Tokyo in just 5. While the X-59 won't carry you, the data it collects will pave the way for a new generation of commercial supersonic jets, quiet, efficient, and sustainable. Companies like Boom Supersonic are already watching closely, ready to build on NASA's breakthroughs. The X-59 could become the ancestor of a new family of airliners that rewrite the rules of global travel. But this story is about more than just speed. It's about a rebirth of ambition in aerospace. The X-59 represents a return to the audacious spirit of the legendary X-Planes program, which has always pushed the frontiers of flight. This time, the challenge isn't just how to go faster, but how to do so gracefully, quietly, and sustainably. NASA is also focused on fuel efficiency and reducing the environmental impact. The X-59 is designed to fly at around 55,000 feet, where the thinner air reduces drag and its design minimizes environmental disturbances. The X-59 is a symbol of harmony between human innovation and the laws of nature. It's a testament to what we can achieve when we dare to dream big. The quiet thump of the X-59 is the sound of a new age of aviation beginning, an age where the world feels a little smaller and the sky a little closer. 78 years ago, a thunderous boom ripped across the Mojave Desert, signaling that humanity had broken the sound barrier. It was a raw, powerful moment that defined an era of speed. Today, in that same desert sky, history is being made again, but this time, you can barely hear it. This is the story of the NASA X-59, the aircraft that is breaking the sound barrier in a whisper. When NASA announced the successful first flight of its experimental X-59 Quest aircraft, the global scientific community watched in awe. For aviation historians, it was a profound moment of déjà vu, echoing the legendary flight of the Bell X-1 in 1947. But the story couldn't be more different. Where the X-1 announced its arrival with a deafening sonic boom, the X-59 slips past Mach 1 with a sound no louder than a car door closing a block away. This isn't just an engineering feat, it's a fundamental shift in our philosophy of flight. What began as a raw pursuit of speed has evolved into a quest for coexistence, a balance between technological progress and a peaceful society. This quiet revolution didn't happen in a vacuum. The X-59 is a testament to a powerful collaboration between public research and private innovation. The project is led by NASA, drawing on decades of unparalleled aerodynamic research. But the aircraft itself was built by the legendary Skunk Works, Lockheed Martin's Advanced Development Division, the same minds behind iconic aircraft like the SR-71 Blackbird. Without NASA's theoretical groundwork, the dream of quiet supersonic flight would have remained on paper. Without Skunk Works' engineering prowess, it might never have taken shape. Together, these two giants of aerospace have created something that transcends their individual legacies, a powerful symbol of what humanity can achieve when knowledge and imagination unite. So, how does it work? The magic lies in the X-59's unique shape. It is incredibly long and slender, almost 100 feet long, but with a wingspan of less than 30 feet. This elongated design, especially its razor-sharp nose, is engineered to manage the shock waves that form when an aircraft flies faster than the speed of sound. Instead of allowing these shock waves to coalesce into one massive, loud boom, the X-59's airframe separates them, causing them to reach the ground as a series of much weaker, gentler pressure waves. NASA calls this a sonic thump. It's the key to unlocking supersonic travel over land. A ban that has been in place for over 50 years due to the disruptive noise of sonic booms. The X-59 isn't just an aircraft. It's a scientific instrument designed to prove that speed and silence can fly together. The initial test flights are just the beginning of a much larger mission. After a series of baseline tests to ensure its safety and performance in the skies over California's Edwards Air Force Base, NASA will move into the next critical phase, community response studies. The plan is to fly the X-59 over several U.S. cities, with potential locations including Texas, Ohio, and Florida. On the ground, an array of highly sensitive microphones will meticulously record the sound signatures. At the same time, residents in these communities will be asked to report what they hear, or more importantly, what they don't hear. Was the sound noticeable? Was it ignorable? Was it just another background noise in their daily lives? This data is the golden ticket. It will be compiled, analyzed, and shared with aviation authorities around the world, including the International Civil Aviation Organization, or ICAO. The goal is to provide regulators with the definitive proof they need to rewrite the rules and lift the ban on commercial supersonic flight over land. If they are convinced, the implications are staggering. We could see the re-establishment of commercial supersonic routes over continents for the first time since the Concorde was retired. It's no exaggeration to say that this single experimental aircraft could reshape global travel and even human geography itself. Imagine a world where cities separated by vast oceans or multiple time zones become, effectively, next-door neighbors. A business trip from New York to Los Angeles could take less than half the time it does today. A family visit across the country could become a simple day trip. This acceleration of travel would have a ripple effect across every aspect of our lives. Business, tourism, and cultural exchange could flourish in ways not seen since the dawn of the jet age. The world would feel smaller, more connected not just through our digital networks, but through the physical reality of the skies themselves. The X-59 isn't just about getting from A to B faster. It's about fundamentally changing our perception of distance and time. Yet, amid all this revolutionary potential, there's a refreshing humility in NASA's approach. The agency is quick to emphasize that the X-59 is an experiment. It's a single, crucial step in a long journey, not the final destination. The challenges that lie ahead are real and complex. Getting a new generation of quiet supersonic airliners certified will be a massive undertaking. Making them economically viable and environmentally sustainable will require even more innovation. But every great leap in aviation history began with exactly these kinds of experiments. The Wright Flyer, the Bell X-1, the Space Shuttle, they were all prototypes, testbeds that taught humanity something fundamental about the art of flight. The X-59 proudly continues that lineage, proving that even after more than a century of aviation, there are still new frontiers to explore, still mysteries to solve in the way air flows, and still grand dreams to chase in the vast blue expanse above us. And perhaps the most inspiring thing about this aircraft is what it symbolizes, the quiet courage of progress. It doesn't roar into the history books. It glides there, serene and purposeful, its whisper carrying a message far louder than any boom. In a world grappling with environmental challenges, urban noise pollution, and a sense of technological fatigue, the X-59 offers a vision of innovation that is both gentle and powerful, both ambitious and responsible. It suggests a future where our greatest advancements don't have to be our loudest. The impact of the X-59 extends far beyond commercial aviation. In classrooms and laboratories around the globe, a new generation of students studying aerodynamics and acoustics are now looking to the X-59 as a living, flying example of how theoretical science translates into tangible, world-changing engineering. The data gathered from its flights will likely influence the design of not just future airliners, but also next-generation drones, military jets, and even the hypersonic craft that may one day explore other planets. The principles of quiet shockwave shaping could be applied to vehicles re-entering Earth's atmosphere, or even those entering the thin skies of Mars, where unique aerodynamic challenges await. In this sense, the X-59 isn't just a new chapter in the story of flight. It may very well be the prologue to humanity's future in multiplanetary aviation. For now, as this sleek, white jet rests under the California sun between test flights, you can't help but marvel at its quiet beauty. Its impossibly long nose points toward tomorrow, its wings reflecting the brilliant light of both science and imagination. Somewhere, in the hush that follows its flight, you can almost hear the echo of human aspiration, the same voice that once shouted, "Let's go faster," now whispering, "Let's go quieter." As the data pours in and more flights take to the sky, the X-59 will continue to challenge our assumptions about speed, sound, and sustainability. And one day, when the first passengers board a commercial quiet supersonic airliner, streaking above the continents without a single sonic boom to disturb the peace below, they will owe that miracle to this small experimental plane and the visionaries who dared to believe that silence could fly. In a century often defined by noise, digital, industrial, and informational, the X-59 is a beautiful reminder that progress doesn't always have to roar. Sometimes it hums, sometimes it whispers, and sometimes, in the quiet sky high above the desert, it sings of the future. Thanks so much for watching. If you found this journey into the future of flight as fascinating as we did, please hit that like button and subscribe for more stories about the amazing science and technology shaping our world. We'll see you in the next one.